All right, up on the roof we are. Got a couple of pieces of equipment up here. Brian, tell us what this piece of equipment is.
This piece of equipment is one of the Renew Air energy recovery ventilators. And if you take a walk over here, I'll show you how this works. As soon as we take the screw back out of the door. Basically what this system will do here, as I mentioned before, is this is going to recover up to 85% of the actual energy, heating and cooling energy in the space.
So this is connected to the ductwork that we saw?
Exactly. This is tied into the duct system that we saw before. And what it does is it brings outside air in through the outside air louver, filters it, and puts it through this is what's called the core of the energy recovery ventilation system. And it also actually filters the air that you're exhausting, so it doesn't plug the core up with any dust or debris that's being pulled from the school space.
So this will need some maintenance.
Absolutely. These filters will need changed every 3 months, the core once a year. And basically what you have is you have 2 blower motors in, one's for supply air, one's for return air, and we'll have to, once we get the system up and running, we'll have to do an air balance on that to make sure that the system's working properly.
So one's connected to a fresh air damper that's sticking outside on the roof, and the other unit is connected to the ductwork that we saw.
That's correct.
And any precautions that people should take with, other than the wind blowing the door shut on you?
Other than the wind blowing the door shut, just preventative maintenance on the system. Obviously, belts, grease and bearings, motors, obviously filter changes, core changes, operational checks, making sure that the voltages, amperages, and stuff like that are all within the specs of the units. But pretty much these will, we're going to set these up on a time clock basically, so that when school is in the occupied mode, the system will run and do the energy recovery, and then when the system closes down for the end of the day, we'll turn them off.
Okay, and what are these large towers?
These large towers are the second half of the ductless split systems that we've installed here, and there is a total, I believe these are 2 7.5 tons, and this is a 9. So there's 15, about 24 ton of cooling. That's solely, these 3 systems are solely for the first floor. And what you have here is you have your typical refrigerant piping with a suction and liquid line, and these lines are a little bit different because they actually have an oil equalizer line to make sure that we get oil return back to all the individual compressors. So this is a 3-pipe variable refrigerant flow system. So these compressors will ramp up and down depending on the load of the space, which units are calling for heating, which units are calling for cooling. So each one of these systems could be running at 5, 10, 15, 20% depending on the load in the space.
So this is all high efficiency?
Absolutely. High efficiency, new R410A refrigerant, so it's not the old 22 that's in typical residential and lighter commercial units. It's all 410A refrigerant.
And it looks like there's lots of roof space left and very few roof penetrations that you've had to put in up here to air condition a school. So typically, wouldn't you see a lot of rooftop units with a lot of place for water leakage or rain to come down through?
Absolutely. The original quote that another contractor had done for them had figured on doing multiple split systems, typically residential type split systems with air handlers for the classrooms, condensing units on top of the roof here. Served in multiple penetrations for all those refrigerant line sets, all the electrical for the condensing units going down through the roof to each classroom. There probably would have been 20 condensing units up here on this roof, plus 20 roof penetrations. We were able to do it with 2 penetrations for the line sets, 1 roof curb for each energy recovery system. So we essentially made 4 penetrations versus 20.
And they would have had a lot more ductwork.
Absolutely, they had tons of ductwork.
Great, and you can see the refrigerant lines go down through the roof over here, and there's a temporary block here until everything is finished piping, and then will be filled in, so it'll be a very small penetration that goes through the roof that will take care of the refrigerant lines versus having tons and tons of space for ductwork.
Yeah, essentially if they would have done something different, like with a typical air handler condensing unit location, you would have had 20 of these penetrations to do these classrooms versus we had it in 2.
Terrific. So 20 penetrations equals a lot of heat loss.
Absolutely.
As well as
potential for
potential
leaks.
for leaks.
Absolutely.
Exactly. So this is saving energy a couple different ways.
Absolutely.
Not to mention installation cost.
Yeah, not to mention the installation costs, having the roofer out here. Now these units here as well, as you notice, they're on equipment rails. Now these equipment rails are actually set over top of the main structural steel beam, and across the main block wall that supports the building itself. So a lot of structural steel support that was thought of and put into place before this equipment was actually even set on there.
Each unit has a separate electrical disconnect, so you can work on these independently if need be. Very safe way to work.
Absolutely. And we also have convenience outlet as is required. So if we have to hook pumps up or for some reason get up here in the dark, we do have a convenience 115-volt outlet that we can plug in any accessories that we would need to.
Great. All right. Thank you.